I'm Matthew, and I'm going to talk to you a little bit today about my research in detecting GenAI manipulation, and also a little bit about my paper on exploring dataset diversity. Okay, so a little bit of introduction. I've just started my second year of my PhD, so I'm just coming up to where the volcano is. Hopefully, it's going to be a good thing, but could go either way. So what does my research include? Basically, anything to do with GenAI and images. So fully manipulated, partially manipulated. If it's got GenAI and it's an image, looking at detecting it. The target audience is basically all of you. So academics, practitioners, my work, I want it to be something that can actually be applied, something that practitioners can actually use and understand. So I know a lot of papers, practitioners just don't have time to read them. So I'm looking to kind of come to the conclusion of something that can be used across the field. So to start off with a little bit of an introduction here on GenAI manipulation. So there is two main use cases. We've got the malicious and the non-malicious. So obviously the non-malicious stuff is good stuff. So we've got stuff like movies, photography, any kind of entertainment, stuff like that. We have a nice example here of, a nice picture of the grass and you want to make it a cat running through the fields instead. Then we go to the malicious stuff. So this is where it gets a bit more dangerous. So I imagine you've probably seen this image kind of floating around a little bit with the meeting that Zelensky and Trump had. Obviously, this didn't happen, and it was acknowledged that this didn't happen. But if that was out on the news, that's the kind of stuff that can start wars. So it can be very dangerous. We also have, obviously, the propaganda, political stuff. So there was a lot, actually, to kind of stick with the theme here. With the American election, a lot of kind of AI images kind of coming up around that area. And then we have harassment. So this is quite a dangerous one because even though the image isn't real, it can do a lot of harm. So someone can just take an image of you on Facebook or anywhere and just manipulate that and then use it to blackmail you. And that's very dangerous stuff. And then we have our cybercrime. So probably heard a lot of this stuff going around. It's got like phishing, social engineering, all that kind of area. So there was a recent one with the YouTube CEO, and someone had used AI to kind of pretend to be him and then kind of convince people to send money when they normally wouldn't have sent money. So now that we have a little bit of an introduction on that, I'm going to go into talking about my paper. So this paper talked about dataset diversity in GenAI image inpainting, to be specific. So inpainting is actually something like this, where you take an object in an image and you either replace it or completely remove it. So it's quite similar to splicing if you've heard of that manipulation, but using more AI to do it. So when I was looking around the literature, our data sets, they're very specific in different areas. So you'll have a data set that just talks about face swapping, and then one that's just fully generated. And in forensics, you kind of need to know where a tool can work well. So we need a data set that covers a good diverse amount of data. We also need to know what components are useful to include, because we don't want to just include everything, because that would be a massive data set that takes ages to make, and it would probably have a lot of irrelevant information in it. So we're kind of focusing in, looking at what components are important and seeing how these are highlighted. So a quick recap of inpainting here. This is an example that was actually in the data set that we used. So the one on the left-hand side here is the real image. And then we've got the mask, which is highlighting the cow. And then the one on the right here is the removed image. So if you're looking really carefully, you'll notice the shadow of the cow is still there because that wasn't a part of the mask. But then you also have some tools that add a watermark. So if you look very carefully at the bottom left-hand corner there, it says AI generated. You might not be able to see it. But that's kind of a new thing coming into place, especially with the AI Act, which is quite good. But it's worth noting that when we were doing the experiments, that wasn't something that we were looking at. We were looking at the whole image. So not just if it has a watermark. So for the dataset creation, took a handful of different categories from the MS COCO dataset. We went with categories that kind of covered broader areas. And we passed this along with the prompt to remove and the mask into 3 different tools 4 times, just to give us a bit more variation. And that created our data set. So we had all the images we had created, we had all of the masks, and we had all the authentic reference images as well in there. With this data set, we then passed it through some code. The specifics of this code doesn't really matter too much. What's important is it has multiple algorithms. And the reason for that is we didn't want the results to be based on just an algorithm. So if you're looking at just noise analysis, we didn't want all the results to be different types of noise analysis. We wanted it to be diverse across so that we could say, these components that stood out, there's a reason why we should look into them further. So it's important to note, kind of went for a confusion matrix here, where we had the mask as a reference, and if the mask was true, and then the tampered result more than or equal to the authentic result, that was then the true positive and so on. So the mask is a key point in there. And with this code, it also gave us an output. So we passed the images into the code, and it gave us a probability map, basically just a bunch of numbers based on either pixel by pixel or pixel blocks, where the higher the number, the more likely it is to be tampered, according to the algorithms. And with those numbers, we could then calculate some statistics, and we could get some evaluation metrics here. So you'll see on the one at the top here, the F1 scores of the image classes actually saw a big difference, where the animals and persons category were way higher than the objects and scenery, kind of showing us there might be something there that we should look further into. Maybe it's something to do with animals and persons being a bit similar shapes or similar masks, and that highlighted some more areas for us to look into. Whereas when looking at the accuracy and of the tools didn't really have that much difference between them. They did across algorithms, but within each algorithm, there wasn't really that much difference. So that told us maybe the tools aren't as important. We'll do a little bit more of an analysis on them, include some more tools and see if that still holds up. But it gave us a rough idea. What I found more interesting, instead of the numbers, was the visual. Because this is the kind of thing that's actually useful in forensics. You're looking at numbers and you're like, okay, it's accurate, but I don't need to know how accurate the tool is. I need to know, in theory, if I'm using it, what am I getting back? So these three examples are the different tools on the same images. I've put the image at the top again there just for a reference so you can see what it is. So you'll see the one right in the middle here, Galaxy AI. It's quite well selected the cow. So the yellow pixels here are tampered and the blue are not tampered. So it's done a good job of selecting the cow. But across all three, you'll see that the sky is identified, but nothing was done with the sky. And that's quite a big hiccup that these tools often come across, where they're like, the sky's probably AI generated, but it just doesn't know, it's too complex for it. Whereas the one here, it's a little bit all over the place. You can slightly see the cow, and the one on this side, you can see there's a lot of false identifications, but the actual outline of the cow, it's managed to highlight that as not tampered, which gives you a little more of an indication of the actual like correlation of the pixels together. So what does this mean for us? So we have certain limitations and certain future work that we wanted to look into. So obviously I've mentioned the reference authentic image a lot. In a forensic scenario, you obviously don't have an image that's not tampered and an image that's tampered. You've just got an image in front of you. So what we wanted to look into is a little bit more thresholding, figure out a way to get these kind of visualizations that we had, but without needing that reference image. Because it's not just about whether it was AI manipulated or not, it's about where. If you have this image of the cow, but you're actually looking to see if the cow at the back has been removed or put in, just it saying, yeah, this has been tampered with doesn't tell you anything. You need to know where it's been tampered. Then we also have the mask size. So something that we identified was the groupings across the categories. So where animals and persons was a lot higher than the objects and the scenery. So we're actually running some experiments right now on this, on the mask size to see if the different object that's being highlighted makes a difference. So the example we had of the cow there, that was quite a big mask right in the middle. But if we just remove like a pen from a table and it's a full picture, does that make a difference? So we're wanting to look into that. And something that I'm actually really interested in looking into is the actual complexity of the object. So stuff like reflections. AI struggles a little bit with that. There was a recent paper that was looking at the reflection in eyes for people and seeing how that's different. So AI actually really struggles with reflections. So seeing if we can pull in complexity of objects, but not wanting to just focus on that. So where am I going from here? So I've got 4 main milestones for my project. The first one being the data set, basically starting from scratch. We want to be able to see what there is and why it's working the way it is. So with a data set, we're going to be able to actually move on to step 2. We were benchmarking the detection and localization techniques. With this, we basically just want to see where current techniques are. And a lot of papers just talk about AI techniques. I'm interested in forensic techniques, forensic tools, stuff like that. Algorithms as well, which will be included. But realistically, what we're looking for is something that's useful to practitioners. AI and algorithms, it needs to be understandable by them and they need to be able to use it. You're not going to get a lot of luck standing up in court and saying, I used this AI, it told me that this is fake, so it's fake. They're going to be like, okay, how do you know that? And we'll be like, well, I don't know, there's all these hidden layers, don't know what they do. But it came to that result. So we're looking for across the board what detection and localization techniques there is and why they're working, why they're not working, where they're struggling, where they're doing good. And then that brings us on to step 3, where we're going to look into hybrid methods. So for this, I'm looking at combining methods. I don't want to go out and reinvent the wheel. If we have something that's working pretty good, but it's maybe struggling a little bit with eyes or skies, I want to combine methods and figure out, well, how can we bring something else into that can level that out? And we can be like, okay, we're no longer struggling with detecting skies because this method does that. So kind of combining them together. And lastly, this one, which is actually going to be the end of my project and my favorite one out of them all, is the framework. We need something that is written down for practitioners that practitioners can understand. None of these academic papers that they can't read and they don't have time to read. Something for them, aimed at them, that is actually useful. Something that has tools, where to use the tools, how to use the tools, how to authenticate the tools, scenarios for using them. If they're dealing with a case that has people in it, and they're using a tool that only works for detecting cars, it's not going to be very useful to them. So having something on paper, written down for the practitioners that they can actually use. And that is everything. Thank you very much.